Hello everyone! Today, we are going to determine the time setting of cement. Cement is one of the most essential materials in construction. But did you know it doesn't harden instantly? The setting time of cement is critical to ensure proper placement and strength. That's where we use the Vicat apparatus. The Vicat test helps us determine two important points, the initial and final time setting.
Let's take a look at the materials we'll need for this test. Materials required: Vicat apparatus, Vicat mold and glass plate, cement, water, weighing balance, stopwatch, and spatula. Step 1. Mixing the cement base. Start by weighing 320 grams of cement. Add water equal to the previously determined standard consistency. Mix thoroughly for about 3 to 5 minutes until a uniform paste is obtained. Take note that we should start the stopwatch as soon as the water is added, as this marks the zero time. Step 2. Filling the Vicat mold. Place the Vicat mold on a non-porous glass plate. Quickly fill it with the paste and level the surface using a trowel. The initial setting time test. Attach the initial setting time needle and bring it into contact with the surface of the paste. Release the needle gently and observe the penetration depth. Repeat every 2 to 5 minutes, and the initial setting time is when the needle penetrates only 5 to 7 millimeters from the bottom. The final setting time test. After initial setting, replace with the final setting time needle, which includes a circular attachment. Repeat the procedure at regular intervals. The final setting time is reached when the needle makes only a slight impression and does not penetrate into the paste. Record both times accurately using the stopwatch. Once the test is done, clean the mold, needles, and tools thoroughly to avoid hardening of leftover cement. Calculations. The formula for standard consistency is equals to the quantity of water for 5 to 7 millimeter penetration divided by the weight of cement multiplied by 100. Specifications. For standard consistency, we should have 25 to 35% consistency. For penetration depth, we should have a 5 to 7 millimeter penetration from the bottom or 33 to 35 millimeters from the top. Results and discussions. For our tests, we used wholesome type 1 cement with fly ash and conducted 5 trials, each weighing 320 grams of cement. For trial 1, we used 29% water and a volume of 92.8 milliliters, which resulted with a penetration depth of 24 millimeters and a normal consistency percentage of 29%. For trial 2, we used 30% water with a volume of 96 ml and a penetration depth of 26 millimeters, which resulted with a normal consistency of 30%. For trial 3, we used 31% water with a volume of 99.2 ml and a penetration depth of 20 millimeters that resulted with a normal consistency of 31%. And for trial 4, we used 32% of water with a volume of 102.4 ml, which resulted with a penetration depth of 17 millimeters and a normal consistency of 32%. And lastly, for trial 5, we used 33% of water with a volume of 105.6 ml and a penetration depth of 10 millimeters, which resulted with a normal consistency of 33%. The test results show that trials 1, 2, 3, and 4 does not pass the required normal consistency because it does not achieve the standard penetration depth, which is 9 to 11 millimeters. Meanwhile, at trial 5, the normal consistency was achieved as it satisfies the standard penetration depth of 10 millimeters.